Okay, guys, the last kind of test we're going to learn about is the chi-square independence test. And the chi-square independence test is used to test whether two variables are independent from each other. The variables are both qualitative variables. If the variables are independent, then there is no relationship between the variables. If the variables are dependent, then there is a relationship between the variables. Now, when it comes to computing the chi-square test for independence, we're going to be using the same formula to compute our test value, except when it comes to computing the expected frequency, we must use the following formula: the row total times the column total divided by the grand total. Now remember, you're trying to determine if there is a relationship between two qualitative variables: gender and binge drinking, marital status and gender, marital status and race, feelings about legalization of marijuana, and your racial ethnicity. Those are all categories. Those are all qualitative. They're qualities. And to find the degrees of freedom when you're performing a chi-square independence test, it is the number of rows you have minus 1 times the number of columns you have minus 1. So in this video, we're going to perform the p-value method, and we're going to be looking at hypotheses for independence test when the proportions are different. And then in the next video, we're going to be looking at when the proportions are said to be the same, but we're going to be using our traditional method. A researcher wishes to see if there is a difference between men and women in the number of cases of mental health disorders. She selects a sample of 30 males and 24 females and classifies them according to their mental disorder. The results are shown, which is the observed frequency. At the alpha level of 0.10, can a researcher conclude that there is a relationship between gender and the types of disorders? Use the p-value method. Okay. So here's our table. We have gender, and we have our 3 types of mental health situations: anxiety, depression, and schizophrenia. Before we can move forward, it is best for us to compute the test value first, which means we're going to need the expected frequency. And to compute the expected frequency, it is the row total times the column total divided by the grand total. Okay, so let's do the following format. Let's find the expected frequency for male and anxiety. This right here is male and anxiety. To compute our expected value, we take the row total, which is 30. We're going to multiply that with the column total, which is 20, and divide that by the grand total, which is 54. When it comes to male and depression, we're going to do the same thing. To find the expected count, take the row total of 30, the column total of 21, and we're going to divide that by the overall total, which is going to be 54. Same thing when it comes to a male who has schizophrenia. Take the row total, which is 30, multiply it with the column total, which is 13, and divide that by the grand total, which is 54. Let's do the math for those first 3. And let's round the 2 numbers after the decimal. 30 times 20 divided by 54. That's 11.8 let's take one number after the decimal. We'll say it's 11.1. $30 times 21 divided by 54. Let's take this to be 11.7. And then for the last one, 30 times 13 divided by 54. Let's get that to be 7.2. When you add up the expected frequency for your males, it should equal to 30 because we have 30 males. 0.7 plus 7.2. Very good. That is 30. Now, remember this. For anxiety, the total is 20, as you can see down here. The expected count is 11.1. So if we do 20, which is the total number of people with anxiety, minus the 11.1, which is the expected for males, that means the expected for females with anxiety is going to be 8.9. So basically, what I just said, you can take the total of 20, minus it by the expected count, the expected frequency for male and anxiety, which is going to be 11.1. And when you subtract those, you have 8.9, which is going to be the expected frequency for female and anxiety. You can do the same thing with female and depression. We have 21 people with depression. It is said that expectantly 11.7 males have depression. So when we subtract that, 21 minus 11.7, that is going to equal to 9.3. And that is the expected frequency for a female with depression. And then we can do the same thing with the last one. Because we have 13 people in total that has schizophrenia, we're expecting 7.2 men to have it. So we can take the 13 minus the 7.2, and that should be 5.8. Why did I do it the other way? 7.2. And that equals to 5.8. So we are expecting 5.8 females to have schizophrenia. And when you add these together, let's add them together because I didn't do that. 8.9 plus 9.3 plus 5.8, that equals to 24 because there are 24 females in total. Now, we're going to do the observed minus the expected once again. So for male and anxiety, the observed was 8 minus the expected, which is 11.1. When we subtract that, that's going to equal to negative 3.1. When it comes to females that have anxiety, the observed is 12. The expected is 8.9. So that's going to be 12 minus 8.9. And that's going to be positive 3.1. Let's do the same thing for the depression. Observed, male in depression is 12. The expected for male in depression is 11.7. When we subtract that, that's going to be positive 0.3. For female and depression, the observed is 9. The expected is 9.3. And that's going to equal to negative 0.3. For male and schizophrenia, the observed is 10. The expected is 7.2. That's going to equal to 2.8. For female and schizophrenia, the observed is 3. The expected is 5.8, which means when we subtract, that's going to be negative 2.8. After you do that, you want to square all of those differences. So that is going to be negative 3.1 squared, which is going to be 9.61. This will be 3.1 squared. That's going to be positive 9.61. This will be 0.3 squared, which is 0.09. This will be negative 0.3 squared, which is also 0.09. Over here, this will be 2.8 squared, which is 7.84. And down here will be negative 2.8 squared, which is 7.84. And the second to last part is going to be the squares divided by the observed frequencies. So for male and anxiety, that's going to be 9.61 divided by the expected count. For male and anxiety, that is going to be 11.1. For female and anxiety, the square was 9.61 divided by the expected, which is 8.9. For a male with depression, the square is 0.09. And the expected frequency, that was 11.7. For a female with depression, the square was also 0.09. And the expected frequency was 9.3. For a male with schizophrenia, the square was 7.84. And the expected is 7.2. For a female with schizophrenia, the square was 7.84. And the expected count was 5.8. Let's divide all these and get 3 numbers after the decimal. 9.61 divided by 11.1. 0.866, because that 7 makes that 5 round up to a 6. 9.61 divided by 8.9. 1.07. Well, this 7 will make that 79 round up to an 80. So 1.080. 0.09 divided by 11.7, approximately 0.008. Then we have 0.09 divided by 9.3. That is 0.010. 7.84 divided by 7.2. That is approximately 1.089. 7.84 divided by 5.8. That is 1.352. Oh, this is a lot, and it's annoying as hell. Now, we have to add all those up. So let's do it in the calculator, actually. Let's add them all up. So 0.866 plus 1.080 plus 0.008 plus 0.009 plus 1.089 plus 1.352, and that is going to be 4.404. That's our test value. Okay, now we're doing the p-value method in this case. So step number 1 says state the hypotheses and identify the claim. The proportions are different from each group because the expected counts for each group are different. As you can see, each group has a different expected count. So when we write our null hypothesis, we're going to state gender is independent from mental disorders. Let's write that down here. Or you can say in a different way, which I'm going to write that in red, that there is no relationship between gender and mental disorders. That's one way we can write that. That's the alternative way we can write that, or a different way. The alternative hypothesis will state mental disorders is dependent on gender. And another way you can write that is there is a relationship between gender and mental disorders. So either way is up to you. Step 2, compute the test value. We just did that. That is 4.404. Step 3, we want to find the p-value. So first, we must find the degrees of freedom. It is the number of rows minus 1 times the number of columns minus 1. Let's go back up to our table. The original table, looking in terms of the categories, this table is a 2x3 table. Let's do that again. Only look at the data values, not the totals and not the categories. This table right here is a 2x3, such that this table has 2 rows and 3 columns. So to find my degrees of freedom, put 3 here, put 2 here. The number of rows minus 1, so that's 2 minus 1, times the number of columns, which is 3, and that's minus 1. 2 minus 1 is 1. 3 minus 1 is 2. 1 times 2 is 2. My degrees of freedom is 2. After we find the degrees of freedom, determine which two values the test value will be in between. Use that to determine the interval of the p-value. This is a chi-square test. Degrees of freedom is going to be 2. Our test value is 4.404. So we're going to zoom in and find two values that 4.404 will be in between. Now, if you notice, 4.404 will be in between these values right here, between 0.0211 and between 4.605. Now, the alpha levels of each of those are right here. So we can say that the p-value will be in between, in order, 0.10 and 0.90. Wow, that's a lot. That's a huge difference between 0.10 and 0.90. I could use that as the p-value interval, but I don't think I want to in this case. Well, I know the p-value is bigger than 0.10. So instead of having this large interval like this, I'm going to write that as the p-value is larger than 0.10. Because there's a huge difference between these numbers. And 4.404 is extremely closer to 4.605. So let's just say in this case that the p-value is greater than 0.10. Step number 4, make a decision. If the p-value is less than alpha, we're going to reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. Alpha is 0.05. Our p-value, this value right here, is a value that is greater than 0.010. And as you can see, 0.010 by default is bigger than 0.05, which means that the p-value will always be bigger than alpha. If the p-value is bigger than 0.10, well, that means the p-value would most definitely be bigger than 0.05, which means we're going to reject the null hypothesis. Sorry, do not reject the null hypothesis. Which means we're going to go up to our hypotheses. If we do not reject the null, we are accepting it. And we're stating that gender is independent from mental disorders. There is no relationship between gender and mental disorder. All right, guys, that is it for the first section for the chi-square test for independence. And I'll catch you in the next one, which is the more important one. Take care.